All right, hey guys, this is the second video on the mole, just to explain some more calculations to you. This is going to be a much shorter video, hopefully. The objectives are, I'm going to give you some notes on conversions, which is like 2 slides. Example number 3, which is on page 17. It's labeled in Sharpie. It says example number 3, and it's 4 slides from a PowerPoint is just wrong. So Anna pointed out that it's incorrect, and I thought I was going to have time to correct that. But there's just no way for me to correct that over the internet, so just mark that out. It's beyond repair. And then I'm going to go over some calculation and practice from the mole calculation practice worksheet numbers 3 and 5. That's on page 18. If you number just like mine, it's labeled mole calculation practice worksheet. Okay, so I'm going to give you some notes really quickly. So why are we converting? Why would we do more conversion factors? It's all about practicality. We can use grams, but we can't really use moles in the lab, okay? So when we have N, and you should recognize N as moles, and we want to go to grams, how are we going to get there? Well, we're going to set up a conversion factor, okay? So if we know moles, and we want to go to grams, all we do is multiply it by the molar mass. So if I have 2 moles, or 2 N of carbon, I multiply it by its molar mass, which I find from the periodic table, which is 12.0111. Okay, if I have 2 moles of sodium chloride, I would multiply by the molar mass to figure out how many grams of sodium chloride I have in 2 moles of sodium chloride. Okay, so if it's 4 moles, we multiply 4 times molar mass. If it's 4.5 moles, we multiply 4.5 times molar mass. Now, if we want to go from grams to moles, what are we going to do? It's kind of obvious. We can do the opposite, and the opposite of multiplication is division. We're going to divide by the molar mass. So if I have 42 grams of carbon, okay, I have 42 grams of carbon, and maybe you're doing this as I go through it as well, and you can pause me. All right, we have 42 grams of carbon. I want to know how many moles I have. I'm going to divide by the molar mass. So what's the molar mass of carbon? We find that from the periodic table. It's 12.0111. So I do 42 divided by the molar mass, and I get 3.49 moles. Okay. If I gave you 3.49 moles and I wanted to know how many grams is that, I'd multiply 3.49 times 12.011, and I'd get 42 over here. Okay. Now to do kind of in a different direction, if I have moles and I want to go to particles, what I'm going to do is I'm going to multiply by Avogadro's number, which I went over in the last video very quickly. It's 6.022 times 10 to the 23rd. And if I want to do the opposite, I want to go from particles to moles, then I'm going to divide by Avogadro's number, 6.022 times 10 to the 23rd, which is a large number, which means you can be using a calculator. And I really hope that you're just, Googling one and using it, okay? So if I want to go from particles to grams, well, what do? I've got to go through 2 steps. I've got to go dividing by Avogadro's number and then multiplying by molar mass. Okay, do we see that? If I have grams and I want to go to particles, I've got to go this way. Okay, I can't go directly from grams to particles or from particles to grams. The mole in is the way we get everywhere. Okay, so we're going to do one example really quickly here. It says you have 3 moles of carbon. How many grams of carbon do you have? You can stop me, okay, and pause me and set this up. We're going to set up a conversion factor. We have 3 moles of carbon. MOL is our abbreviation for mole. We're going to set up a conversion factor. What goes on the bottom and what goes on the top? Okay, so we want our unit we want to end with on the top, which is grams. It asks us how many grams of carbon do we have. I'm going to put that up top. On the bottom, we want the unit we want to cross off. And what are we going to cross off? Well, we want to cross off moles. So we're going to put moles on the bottom. So what we set up here is a conversion factor, right? Okay, this should be equal to 1 right here, should be equal to 1. So 1 mole is equal to how many grams? Well, that's your molar mass, 12.0111 grams of carbon. Our units cross off. We multiply across the top, 3 times 12.0111, divide by the bottom, which is just 1, and we get 36.0333 grams of carbon. You can pause me, I know I'm moving quickly. I'm going to go into the mole calculation practice worksheet really quickly, okay, and I'm going to be pausing myself, so when I say pause, it might be a good time for you to pause, because when you come back, the calculations are just going to pop up really quickly for you. So number 3 says, how many molecules are in 23 moles of oxygen? Okay, we want to start off by writing what we know. We know that we have 23 moles of oxygen. Oxygen is a Brinkelhoff. Okay, that's important. So let's write out what we know it's 23 moles of oxygen. Okay, I've written out 23 moles of O2, and I don't know why it's cutting off the last half of my word, but that's the best I can do right now. I've got 23 moles of O2, okay? What do I want to convert to? I want to convert to molecules, okay? So what's going to go on the bottom and what's going to go on the top is what we're going to think about right now, okay? So let's set up that conversion factor. Okay, I've set up my crossbars here. Now what's going to go on the top and what's going to go on the bottom? Well, we know we want moles to cancel out, so we know moles is going to go right down here, right? Okay, I'm going to do that. You might want to pause. 1 mole of O2 down here, and what's going to go up top is molecules. That's the unit we want, molecules. So how many molecules is in 1 mole of oxygen, of O2? Well, we should know that in 1 mole, there are 6.022 times 10 to the 23rd molecules in 1 mole of anything, and we call that Avogadro's number. Okay, so I'm going to put that in. Got this plugged in. What am I going to do next? Well, I'm going to cross off the things that cross off, right? Oop, I'm having a hard time, y'all. So what crosses off is our unit for mole, okay? And what are we left with? Well, I should have written molecules up here. So the unit that I have up here is molecule. So let me do that next time. And what are we going to do? We're going to do 23 times 6.022 times 10 to the 23rd. You're going to need to put that into a calculator probably, right? Okay. When I get back, when we get back, I'll show you how to do this without putting it in a calculator, but you're welcome to do that right now, okay? What I get is I get 1.385 times 10 to the 25th molecules of O2. So there are 1.385 times 10 to the 25th molecules of O2 in 23 moles of O2. Okay, we've done a conversion factor. This is how many molecules exist in this many moles. Okay, that's what we're doing. Number 5, jumping down there, it says how many molecules are in 25 grams of NH3. We've got to start with what we know. And what do we know, y'all? We know we have 25 grams of NH3. So let's write that out. Let's set up our crossbars just like we did here. You may want to pause me. It's going to come up quickly. So now we've got our crossbars up. We've got what we know here. Now what we start with has to go on the bottom of this next one. So what's going to go here, or what unit is going to go here? Well, we know it's going to be grams of NH3. And what do we want to go up top? We want molecules to go up top, but there's a problem there, right? Okay, we don't know how many molecules is in 1 gram of NH3, okay? But what we do know is we do know how many grams is in 1 mole and how many molecules are in 1 mole. So what we're going to do is we're going to convert to moles first and then to molecules. Okay, so what's going to go on the bottom here is grams. So what's going to go up top? The unit we want next, which is moles. Whenever you're stuck somewhere, convert to moles. So let's do that. You may want to pause me. Grams of NH3 down here is equal to 1 mole of NH3. Well, I need to know how many grams is in 1 mole. And how do I know that? Well, I've got to find the molar mass of NH3. So how do I find the molar mass of NH3? Well, if you need help with that, you need to go back to the last video I posted. But we know nitrogen is found on our periodic table. And I believe it's 14.007 grams. And hydrogen's on our periodic table. That's 1.008, okay? We have 3 hydrogen and we have 1 nitrogen, okay? So if we have those, we can figure out our molar mass. Now we have the molar mass of NH3, right, which is ammonia. Yeah, ammonia. Well, I'll have to think about that. So we know there are 17.031 grams of ammonia in 1 mole of ammonia. Now, what unit do we have here? We know grams are going to cancel out. We have moles, but we want molecules. So we're going to convert to molecules. So let's set up another crossbar. I'm going to extend this crossbar. Okay, so let me just do that now. Maybe it's helpful to see me do that. All right, and then I'm going to make another crossbar here. Okay, so this is 2 conversions. Now what's going to go down here is the unit that we have. Now remember that we have crossed off moles, grams. We no longer have grams, okay? What unit are we left with? Moles. So what's going to go on the bottom? Moles is going to go on the bottom. What's going to go up on the top? Well, the unit we want, which is molecules, right? So moles on the bottom, molecules on the top. What have I got here? I've got 1 mole is equal to 6.022 times 10 to the 23rd molecules of NH3. This is just a conversion factor. Now, which cross off? We've got moles crossing off, and we end up with the correct units, which is molecules. We just need to multiply the top divide by the bottom. We've got something different here. We do have a number that's not 1 on the bottom, so we need to divide by that. So 25 times 6.022 times 10 to the 23rd molecules divided by 17.31. How about you try that? The answer is going to pop up very quickly. End up with 8.84 times 10 to the 23rd molecules of NH3. That's the number of molecules in 25 grams of NH3. Remember, we can't go directly from grams to molecules, so we had to use an additional conversion factor of going to moles. This is the extent of what you'll see, okay? That's the last thing I want to show you. I am going to upload one more video tomorrow with just an update on what the heck is going on, y'all. I will be live still on Monday at 1:30 just to answer any questions, and that'll be the last of pretty much anything for a while. Until I'm told to do anything else, I don't plan on sending out any more work. So do be checking in, do be looking on Google Classroom, but this is kind of it, y'all. So once you get this, you're good to go. So from here, you can complete the rest of the assignments. Take your time on assignment number 10. Assignment number 10 is some dimensional analysis. There are 10 questions there. I may adjust that, okay? So be on the lookout for me maybe adjusting that. That's too many problems, all right? I hope you guys have a great day. Hope you're doing good. Hope you're washing your hands.